So here we are together again with one more application of quantum dots, that is in solar cells. As we know that solar power has been long a key component of the transition to clean and sustainable energy sources. So today we'll be discussing the application of quantum dots, that is nanotechnology, in solar cells. Just a sec. But solar cells have been pre-used since long. So why quantum dots in solar cells? Let's try and check it out. Actually, what happens? Quantum dots have tunable band gap. Now, what is tunable band gap? It actually means that their ability to absorb the light can be controlled by changing their size. As we discussed in our previous video also, if we change the size of the particle, then the corresponding wavelength of light which that particle actually absorbs, it changes. So this is what we are trying to say over here, that it means that their ability to absorb the light can be controlled by changing their size. This makes them ideal for being used in solar cells, where they can be tuned, we say, accordingly to absorb a wider range of wavelength of light than the traditional solar cell materials such as silicon. Fine. So that means I can come to the conclusion over here that these cells can replace the bulky materials such as silicon or copper, indium, gallium selenide, and possess the potential to reduce the wasteful heat and at the same time capitalize on the amount of sun's energy for conversion to electricity. Wow, that's amazing. Let's get some more convincing facts. Quantum dots, I came to know that they are capable of generating multiple electron hole pairs per absorbed photon, a process known as multiple exciton generation. What is this multiple exciton generation? Let's try to compare the quantum dots in solar cells with the traditional silicon solar cell. So I have a figure over here on the left which is actually of silicon solar cell. Here you can see that the light energy is absorbed by the electron. It jumps to the higher energy level. Okay, and then what happens? It comes back to the lower energy level and a certain amount of heat is dissipated, which we say that the heat is lost, the energy is lost over here. Okay, now let me compare this with the quantum dot in solar cells. That means when we use quantum dots in solar cells, what happens when quantum dots are used in solar cells instead of the traditional bulk silicon material? The light energy is made incident, which falls on the solar panel. Electron absorbs, gets excited, jumps up to higher energy level, okay, comes downward, that means comes back to the lower energy level, and then another exciton is generated. In other words, we can say that the energy of a single photon can be enough to excite two or more electrons in a quantum dot. These multiple exciton generation can significantly improve the efficiency of the solar cells. Oh, now I understand how this quantum dot is making the solar cells more efficient, because at the same time it is making more than one electron come to the excitation state, or let's say more than one electron hole pair is generated when the quantum dots are used as compared to when the bulk silicon is used. Okay, fair enough to convince myself for the use of quantum dots in solar cells. So now I am convinced with the point that quantum dot solar cells manufacturing refers to the solar cell that uses quantum dots to absorb the photovoltaic material. It's a key innovation area in the environmental sustainability that we need to agree upon. But actually, are quantum dots somewhere affecting the economy of a country? So during last 3 years, as per my research, it says that during last 3 years, 4,39,000 patents were filed and granted in the power industry alone, as per the Global Data's report on environment sustainability in power. The power industry continues to be a hotbed of innovation, oh my God, with activity driven by impact of greenhouse gas, net zero carbon emission goals, and production of greener electricity. That's amazing. Another latest research says that Energy Stakes, a leader in renewable energy sector, marks its latest innovation in this sector, promising solar cells that will be more accessible and efficient for business and homeowners alike. Okay, the engineers at Energy Stakes have achieved a groundbreaking efficiency rate of 25%, making the solar panels now as more efficient options in the market today. That means the traditional solar panels and the solar panels which are being planned and manufactured now using the quantum dots, there's a huge difference of 25% efficiency of energy amongst the two. So these panels are more durable also and can bear extreme weather conditions as well. That means we can say that quantum dots can, yes, effectively change the economy of a country. They can change the technology of a country also. So, summarizing our today's clips, we come to the conclusion that nanotechnology has vast applications in various fields, and quantum dots are actually one of the sections of nanotechnology, a dot that actually deserves a Nobel. So, plan an interesting application of quantum dot for a new business venture ahead and stay connected. Thank you.